When you have multiple slaves connected to the same master controller in an SPI bus, you have a couple of ways to actually connect these slaves to that master. So the first one we're seeing here is actually what we call a parallel configuration. And the reason why it's parallel is the following. So each one of these slaves in here are connected to the MOSI. So all of them are connected in parallel. And as it turns out that this particular controller will have a slave select for each one of them. So this one here selects the first one, this one here select the second one, this one here select the third one. And all of them together have the MISO connected together and all the way to the master. So in this particular configuration, we have 3 slaves and 1 master. We can have more slaves if we choose to, but for simplicity, we're just going to restrict it to 3. Whenever the masters want to communicate, let's say with slave number 1, what it needs to do is just needs to assert this by putting a 0, and this is how you assert it, and then you select that slave. And what happens is now this particular connection happens, and this particular here and here and here, and you do the same exact thing as a single configuration. However, one might have to be careful, because whenever you have the MISO in here connected to this MISO, and let's assume that you're putting, this is a single wire, so maybe this one is outputting 1, this one is outputting 0, there will be a collision. So to avoid these collision, whenever you actually hit this slave select, you are technically connecting, let's say this one here, you're technically connecting that MISO to the bus outside. What I'm saying in here is these should be in a tri-state buffer, so that the ones that are not selected, like for example if you selected slave 1, slave 0 and slave 2 should give you a high impedance in here in both cases. And the only one that is connected to the bus is actually the slave number 1. So this is what we have in the parallel configuration. And in this particular configuration, the slaves are completely independent. They have nothing to do with each other. The master just communicate with each one of them separately. Another possible configuration is what we call the daisy chain configuration. And the reason why it's called daisy chain is because the MOSI is connected in here, but then the MISO of one is connected to the MOSI of the other one. The MISO of this one is connected to the MOSI of this one. In this particular configuration, we only have one single slave select. Once it's asserted, all of them will be selected at the same time. And what's happening in there is whatever is the content of this register after a certain number of clocks, it will be in this particular register, and whatever was in this register becomes in slave 1, whatever was in this register becomes in slave 2. So this is why they're connected in a daisy chain. So conceptually, it just forms a very large shift register, and the data is transferred serially from one device to another. So the devices must be cooperative, and they have to follow a certain protocol because they're communicating with each other. Okay. So these are the 2 configurations that you can have with multiple slaves and 1 master.